Okay, I believe you can hear. Yeah, there's
Yeah,
a confirmation. You can go ahead.
I'm sorry, I forgot to connect the microphone. So, okay, I tried to start again. Okay, so today's my talk is about our recent gait recognition research in my laboratories. And topics is these four related to these four papers. The first three is a diversity of the observation. When tackle to the gait recognition problem, if the view direction is a change or if there's an occlusion, that is a very big difficult problem. And also uncertainty of annotation. That is a very, maybe not familiar with all of you, but that is also a big problem. So I'd like to introduce these three works. And also, if I have a time, I'd like to show one of the application for gait recognition. And that is apply for medical. So, okay, now I would like to start my talk now. First, I would like to introduce the outline of gait recognition. Every time I show this slide, these three guys is my student, age is 23 or 4, and all of them is gender is a male. So how do you think about working style? I think 3-person working style is not same. So why this kind of difference happen? This is main caused by personality. Every one's personalities is appear on gait walking style. Okay. By the way, the advantage of a gait recognition, there's a many different type of the biometrics. Well, DNA, fingerprint, hand vein, or iris or face. This kind of the modalities, we should have to contact the sensor, or we should have to stand in front of the camera. On the other hand, gait is only biometrics we can authenticate at a distance. That is a very good point. For example, in this case, human is very small, and we cannot get the human face. Face is masked and resolution is very low, but the gait recognition can apply. This is one of the advantage of gait recognition. Then the gait recognition is already used in police. This is a first announcement in UK. Actually, the Professor Mike Nixon's group did this work. Then just 4 months later, our group also have some announcement. Our technology is used in police in 2009. Then we developed the world first packaged gait verification system for clinical investigation. In Japan, Japanese police use this verification system now. So in this system, we input 2 video clips. Then after that, this system is a little bit old system. So as you know here, this gate feature, the old style gate feature, the GI we are using. But then of course, this system do not use neural network, so old style machine learning. But one point, this system, good point is we do not directly use this network. We calculate posterior because we have a large amount of the data. So from such kind of data, we prepare the probability density function for same person and different person. Now, from such kind of the data, we can calculate posterior of same person. So that is very important for using it at the police. Okay, now I show you a typical pipeline of gait recognition. If we have this kind of the input image sequence, typically more than 1 gait cycle is required. So because a 2-step is 1 cycle, then the human gate will predict our motion. So 2 steps is a minimum requirement. Then once we get such kind of video clip, we pre-process to the image and extract the normally gate features. Now recently, a gate feature is represented by image sequence, silhouette of the image sequence. But all the time we calculate some kind of the gate features. Then once we get the gate features, we can easily to classification can do. So this recent approach is feature extraction and classification part is done by a neural network method. Then one thing is very important is we normally use silhouette information. Now, why not use a color or texture information? That is people change clothes across days. So every day, you wear same wear every day? Maybe no. So that means we should wear is not good information. So gait recognition is not a person re-identification. In case of the person identification, if the 10 minutes later we do a person re-identification, where close information can also use. But gait recognition is do not use such kind of data. Okay, this is our early study using the CNN-based cross-view approach. In this case, we have this kind of the network. Two network is combined. Then in this case, a verification system. So we calculate contrastive loss. Then combined by square level diffusion. Very, very early in time's work. Then why we prepare the two network? That reason is in case of the this kind of the side view, you can easily to see face position is almost similar. That means that we can directly calculate this symmetry at the beginning. That means some kind of a subtraction between two images enough for calculate the difference. So in this case, then on the other hand, a different view. In that case, face position is quite completely different. So if we calculate subtraction at the beginning, maybe not so good. So we input the different network. Then higher level, we combine these two. So we prepare this kind of the two different type of the network for tackle to the cross view problem. Then by this kind of the method, this red line is traditional style one. Then the dotted line is different cross views, 0 degree and 90 degree. Then on the other hand, this blue line is this method. Then you can easily to feel CNN-based approach. Our method is better than traditional method. So in case of the identification, we do not use contrastive loss. I'd like to show a difference of the identification and verification. So in case of the verification, we can, if the so in this slide, the black is a probe, and red and blue is a gallery. Then the red is the same person. Then on the other hand, the blue is a different person. Then the nearest gallery is all of them is a same person. Then the middle case, middle means the distance between probe and the gallery of the same person, the distance. In this case, and then this dotted circle line is a margin for threshold circle of this signal. So normally, if the inside of this circle, we feel it's same person. So so how about middle case is successfully we can do, but small case, in this case, nearest gallery is the closest one, but other people also inside the circle. That means that this is a false acceptance. Then also largest case, nearest gallery is outside the circle. But in this case is a false rejection. So from this result, very interesting for verification is we require this kind of relation, middle case relation. On the other hand, identification, every time is no problem. Because identification, we check the order of the against the gallery. So smallest one is this one. So order is a person. So if you calculate the rank one, in that case, first, so 100%. So middle case, and this is nearest is same person, that is a rank one. Yeah, and also large case, nearest case is same person. So in case of identification, every case is no problem. That means verification and identification criteria is completely different. So network architecture for identification, normally we use a triplet loss. So we calculate between same subject relation and also different subject relation. If order is okay, in that case, no problem. So we can design by this kind of the dissimilarity, relative similarity score is very important. And same as a verification case, our network is prepared two types, large angular difference, both large angular difference and also small angular difference. We combine these two. And this is very interesting result, accuracy of by using the relation between the loss function and equal rank identification rate relation. In case of the contrasting loss, equality rate is best. And on the other hand, triplet rank loss, rank one identification rate is the best. So from this result, we can easy to understand which loss is good for verification and identification. By the way, we should have every time consider about interpersonal variations. Then previous today's discussion is many people discuss about this kind of thing. So left side image, you can easily to fuse illumination change. Maybe image is changed by the illumination or viewing directions. So even if the same person, dissimilarity is this kind of dissolution is happening. Then of course, different persons, dissimilarity is also coming like this. So we should have to tackle to this kind of the problem. Against the this kind of interpersonal variations, so batch-based approach is very useful. Then the loss function considering the variation with the same person is actually proposed by this paper. Then this case is use a batch or triplet loss. This is actually not my group. Then in this case, a batch or triplets is calculate relation all of them. So in case of the differences, we should have to keep away, and if same class, we bring closer. And on the other hand, another type of the batch triplet loss is a batch hard. In this case, we only check hard situations. In case of the same class, we calculate the other case only. On the other hand, a different class, we consider about the more broadest case. That is batch hard. So this kind of the batch all triple loss and batch hard triplet loss design for identical scenario. So inspired by this kind of the approach, we designed the batch hard type of contrastive loss for verifications. So loss function considering intra-person variation suitable for person verification scenario. So in this case, we consider same as triplet loss, we calculate hard case only. So but basically, idea is very simple. Then we compare we using the different type of the models. So light model, light network. So very simple network is GI is simple CNN. And this is state of the art method, gate set and gate GL. This is a very famous model using the Shred's complex network. Then here is the result on by using our OUMVL database. So you can see here, this is a CN. First row is a standard contrastive loss. Then compare with others. Second one is a batch all triplet loss. Then the third one and fourth one is a batch all contrastive loss. And the final one is a batch hard contrastive loss. You can see here, even if the right complex network and also right network, all the case, this batch hard contrast loss shows a best result. So from this result, batch hard contrast loss is very good for identification task. Of course, apply to any type of the network. But actually, there's some difficulty is also have because batch hard is a very how to say sensitive situation. We only consider. That means how to select the batch size. That is very important. That is one of the difficulty. But if we can find a good batch size, we can get a very good result. In case of the complex network, we should have to use a little bit trick. So in that case, first we use a light network and find the batch size. Then start from that one is more good to optimize to here. So anyway, here this kind of the result we can get. Okay. Now I show you several results. That is one of the view angle difference. And challenging problem is we also have many method thing we have. Close validation, carried object case, and the walking speed is sometimes changed. And in case of the surveillance camera, frame rate is also changed. So there's a big problem. And we did several studies. But today I talking about not that this type, but different type of the problem I would like to discuss now. That is the occlusion. In real situation, you can see here, is this a very natural situations. In this case, a low high edges is in front of this person. So we couldn't observe the legs. This is a very common situation. Another case is this kind of situation. This is a field of cameras here. So that means we couldn't observe the upper body. And also view is slightly changing. This is a real situation. So we should have to handle this kind of the problem. So like over the body shape and pose and motion, that means that is a drop the gait recognition performance. How to tackle this kind of problem? That is a very important for practical use. Then we published this paper, occlusion-aware human mesh model-based gait recognition. So in case of the human base, very interesting work was done. In this case, 3D human mesh recovery from partial image. Only this kind of image is given. In this study, we can get a 3D, this kind of the 3D model. This is very interesting studies. Then in this case, obtain the human body model directly by a model fitting framework, I think. Then inspired by this approach, we want to have the model-based gait recognition against occlusion. Idea is very simple. We use a human model estimate. We prepare the human-based network estimation network. Then we combine. Then first estimate the SMPPL is a human 3D model. We estimate the model, and if model parameter is a shape and pose, we can. Once we get this one, we can easily recognize. This is a basic idea. Then we generate the end-to-end framework. Then before that, when we make such kind of framework, we use this model gate, this method. This is also our group's work. In this case, we require the full body shape. Once we get this kind of image sequence, RGB image sequence, we apply the human mesh recovery network, then recover the 3D model. Then we make this kind of model. Then actually the accuracy is very high, and state-of-the-art recognition performance we get. But in this case, a non-occluded gait sequence case, we extend this work. What we did is first human mesh model recovery is normally applied to the single image, not the image sequence. Then model gate is we apply to the sequence. So that is second improvement we get. Then in this case, against to this kind of the crop partial image, we estimate the parameters. But in this case, we use a sequence encoder, then captures a 3D model. But one of the problem is if we have the occlusion recovery parameters, we need consistency between the sequences is very important. We give the such kind of consideration, and also extracted images phase is not same. So even if the different view occlusion, we try to make the same phase. So phase is also extracted by phase estimator network we use. Then we combine these and estimate phase synchronized parameters. Then once we get this one, we calculate the shape pose. But in this case, another point is that if the occlusion type is different, there's also gives some differences happen. So we apply the alternative transformation and get more occlusion independent parameters. So this is a second part. Then then we get the pose and shape information. We apply the recognition. That is a framework of occlusion-aware model-based gait recognition. So then the occlusion dependency annotation, what we did is minimize the intra-subject variation for body parameters. So we try to minimize the error between, even if the same person, different types of occlusion, we try to minimize the error. Then actually, we have the full body data set, multi large population data set. We crop from the this kind of the image, generates a partial occluded image we generated. Then we apply that method evaluated. This is a SMPL visualization result. And second line is ground truth. And fourth one is our proposed method. And third is using the model gate. So model gate requires a full body. So it cannot reconstruct the exact shape. But you can see here, almost same phase and shape is reconstructed. Then this is also different situation. In this case, you can also see some difference. This is a comparison with a general same occlusion pattern. So pose and shape fusion version shows the best performance. Model gate here. This is appearance-based method, gate set and gate GM. Then this is also same occlusion of the equal error rate. This is a cross occlusion pattern. Even if the cross occlusion, our method shows the best performance. Okay, so we did this kind of the study related to the occlusions recently. Then the next is I would like to show different topics. Sorry, maybe ちょっと待って this moment. Okay, so mainly today's talk is a person identification related to the person identification. But what can we perceive from gate? Against this question, maybe we can, our group also do different type of the studies, that is age estimation or gender estimation. That means human gait includes such kind of the information. That means we can estimate. Then another very interesting point is you can see here, she has some disease. So medical doctor watching her working style, then medical doctor confirm diagnosis. So that means that this kind of gait pattern can be used for medical. Another interesting point is this is aesthetic attribute. So if you see a walking style, how you can feel that she is beautiful or he is gentle or several or such kind of aesthetic attributes maybe you can feel. That not such kind of the attributes is very difficult. So so you can see here, this is very interesting demonstration by Queen's University Biological Motion Laboratories. Sorry, link is oh, okay, sorry. Link is not. At least this group, what they did is they captured many type of the data. Then from male and female, almost 100 subjects. Then they annotated this walking is a male or female, or another thing is walking style is heavy or light, or another is emotion state. Then we can, this demonstration, we can easily to feel such kind of emotion state from the gait walking pattern. So aesthetic attribute is similar to such kind of thing. So what is our goal is from this kind of the gate video, we apply the video-based gate analysis, then estimate the beautiful or good or relaxed or cute or such kind of the attribute. That is our goal. Then we did this work almost 3 years. Then the first work is published on the ICPR 2020. And the second work is IJCB 2021. Then today's my talk is the third work. Then the first work, this is a aesthetic attribute from gate. How gate looks nice? Which one is a nice? Good. Can you feel? Upper? No, maybe all feel upper is better. Then in this case, we can easy to feel. How about this? If you show one video, can you feel? Yeah, someone feel this is very good. Can you easy to select this kind of absolute attribute? Maybe no. Not so. This is very difficult task. But if you show by this kind of the two movie show, we can easy to select. That is very important point to handle this kind of the problem. So relative attribute is about for us more easy to feel. So so for annotator, that is same thing. In case of the data, if we want to use a machine learning technique, we need the data. If the annotator cannot give the good level, that means that we couldn't do the work. So if you make given easier to annotate is very important for making the system. And also, then first step is handling the relative attribute in deep learning. In this case, we use a GEI, and we prepare a network. And first, we calculate the absolute score. Then relative score is calculated, and then we design for key function for relative attribute. This kind of idea we implemented. Then that is the first work. Then the second work is, but maybe in this case, if there is several annotators, every people feel right one is better. So easy to select. But in case of this case, how did you feel? Not so easy. Then maybe each annotator show different result. This kind of the split is often happen. So that is depend on the which relative attribute we calculate. So second work is we prepare the model for this kind of distributed model to the network. That is a second work. And the third work is annotator dependent case. So if you are annotator, how did you think you can do good work? I think someone would do good work, and someone is not so easy. So that is depend on the skill of the annotator. So our final system is consists from the two parts. Sorry. First part and the second part. Then the first part is annotator independent uncertainty layer. This part handles the relative attribute uncertainty model, and also relative attribute distribution. Distribution is a difficulty of the problem. We represent by this kind of distribution. Then this part, relative attribute model. We compare these two. So this is actually same as first word and second word. This part is really improved, but this part we prepare. Then after that, we prepare the annotator dependent uncertainty layer. In this part, we model the skill of annotation. Then, so this is a qualitative evaluation on the annotator data set. This is a 7-grade scale. So this is a relative score of each annotator, and this is the annotator independent relative attribute score. If this image is, this is our result, then this is granted. If this pattern is the same, that means that we can estimate annotators collectively. And this is a baseline different method. You can see here, these two is quite similar. So that means that we can estimate the annotator's skill. So here is a result. Our proposed method show a very good performance. And after we generate this kind of system, now our system is demonstrated in the Umeda, Osaka area. Osaka, Umeda is downtown in North area in Osaka. We have a demonstration system, and this is so that we written by Japanese character Genki. But and also これちょっと短いね。
Okay.
And we also show this is the estimate age also. Walking gate from gate, we estimate age also. So age and such kind of attribute we estimate. Then we have this kind of demonstration. If you have a chance to visit Osaka, you can enjoy here. Okay, so talk is this is final one. Medical support and health cares. What we did, we did several medical application by using the gate features. But today I show you one of them. This is early detection of a low cognitive score from dual task performance data using a spatial temporal graph convolutional neural network. Then, as you know, dementia is becoming a large problem for the elderly. Dementia is a progressive disease. It is incurable, and dementia can be delayed by proper medical intervention. So one of the things is most important point, early step detection is very important. If we can estimate the early stage of dementia, the early stage is sometimes mild cognitive impairment is before dementia. So if we can detect that here, we can back to here, or we can keep this stage. So this is very important. And what is actually a medical area? What they did is they have some anklet system with that is a mini mental state examination. That is a very famous grand gold standard. And if the score is total score is 30, then 27 rather than 27 is healthy, and between 23 to 27 is MCR. Then lower than 23 is dementia. So, but this test is very simply about a 15 minutes test. But for medical, should have to communicate with patient. And another bad point is this anklet is only there's only one type. So that means that if you do every day, it's easy to memorize. So that means that this test is at least 6 months is required for every 6 months. That is required. So that is a big problem. So I'd like to make a new system that is a dual task working system. Only 80 seconds check. Then in this case, we use dual task. That's not actually use the two tasks at the same time. Then our case, what we did is one is stage. Another we show that calculation now in terms of this list. For example, 100. Then we show you 200. Then the 100. We do that kind of two tasks. For example, in this case, we show 93 and 95 and 10. And from the working pattern, actually the taking pattern and also answer calculated result, we estimate their score. That is our system. Very simple. Then how to make our system is actually with the STGCN. STGCN is a very good model. I think you mentioned about that. Then the STGCN is a good model for applying to the action recognition or something. Then we use 25 joint data. Then we continuously observe the certain of the angles position. From such kind of position, we input to the STGCN. And also, we calculate the result of the cognitive data. Then one task is 30-second calculation, single task, and 20-second stepping task. And finally, we do a 30-second graph. How we do a single task is cognitive functions depend on the person. So we should have to compare single and graph. And also, stepping is also exercise abilities depend on the person, individually different. So we do only stepping task and drivers. Then we can easily to know the difference. So we do this, we prepare this kind of task 3 times. So 80 seconds by 3. That is our task. Then this is a result, 2021's result. Very old one, but score is very nice, 1.79, 1.79 sensitivity and specification total score. And seems to be not so bad. Then now our method is moved to the next stage now. Then I would like to show you that result, but now that is a secret. So I couldn't show you because this time we use MMSE score. Now I change it to the conform result. Dimension. No. DNS result. So medical doctor gives a score. So that is very important. Not MMSE is actually that is a screening test. But the medical doctor score is correct. So now we everything changed to the first score. Then now this result is now more than 1.9. So very high score. Then we captured more than a lot of the patient's data we get it. Then maybe in the future, it will appear as medical device, I hope. Okay, so thank you for your attention. If you have any question, please email me. Each corresponding researcher will answer to the detail. Then today's topic is these 4. Then we have a data set. This is a skeletal data set, and this is 3D model mesh-based model. Academic use only, but if you come to here, you can obtain our data set. So thank you very much.
Very much for that question. May I question from the floor?
Yeah, I guess it's, like, my area is also in the recreation, so, like, my problem is about what if we saw a lot of problems, especially in the indoor data set, like, what's up, or UMBLP. But when we facing like the outdoor scenario.
Sure.
Yeah, so what is our next step? Cause the gate recognition is,
Yeah, we do not open the outside data set, but outside is different province included.
Yeah.
And now I think that there's a two data set, outside data set, one data set, the biggest one. From the, I forgot it, no, one data set already available. Then another thing is the synthetic data is also available. If you want to apply the outside, let's use the such kind of data also. Then this is a very simple situation, but easy to evaluate your main basic idea.
but also like when we collect the gate data, it's more complicated. Than the facial or other biometrics, because we cannot recognize a person by her back, like the annotator could not do the thing like the facial one. Right? So it's very hard to create more than 1 million.
It's not so easy.
Yeah.
So in my laboratory is about 20 annotators every day working. They're the data specialists. Someone is more than maybe more than 5 years. They most of sorry. Making the data is very important. Of course, recently you said synthetic data. That is also one of the ideas. But synthetic data we can apply to the training. But verification and test, we need a real data. So both data is very important. And also, today I show you aesthetic attribute. That is very difficult to make by synthesis. In that case, maybe real data is currently most good way to use now. But it depends on the task.
Another question, please. I wonder if you noticed in your work, like cultural differences in gait or situational differences in gait. So if one is around, you know, if a man wants to impress a woman, maybe acts very cool when he's younger,
Yeah.
but then sees his grandpa, then he might stand up or walk in different speeds and
Yeah.
things. What could you say about what you
That is a very
learned about the dynamics?
2005 or 6, I did a very different type of studies. That is a intention estimation from behavior. That is very exciting, but very difficult. And I focused to the convenience store situation. And if you limit the situation, we can do some studies. And also culture is also very important point. And background is also important point. So our case is mostly collected in Japan. So if we want to have a world type of the gate database, we can analyze more. Maybe you are question I can answer, but there's no such kind of.
I was wondering if someone would ever get accused of a crime because they were walking cool
Yeah.
for a minute, but
Yeah.
that coolness happened to match
Yeah.
a criminal or something, right? That wasn't my case.
Okay, let's talk about this.
I would like to ask about the application of these annotations of the certificate. I would like to know the ratio of these annotated data. Since Professor Cho one model which is based on heart posture, heart trigger, which is based on heart posture probably. If let's say you are having a lot of heart posture, then the model wouldn't be performing.
It's absolutely.
I would like to know the ratio of these annotated data.
It depends on what we annotate. There's a simple annotation. So that is, for example, not only the case. A person, we did annotation. What we did is getting the boundary box or other cases, the tracking, send out the value and get the trajectory. Such kind of task is very simple. So even if such kind of task, they are also mixed. So in my laboratory, we did a double check. 2 persons is set, and one check and another check once more. So then try to minimize the such kind of error.
And the second part of the question is that because of the hard triplet, it is very sensitive to the hard positive example. If let's say positive examples are having maybe wrong annotation, what will be the performance for that?
Very difficult. Yeah.
Okay, another question? I think we can entertain one more question, if any, yeah, let's ask a question.
Yeah, so one question, you showed that you can recognize different attributes from data. So and some of those are beautiful, cool.
Yeah.
So how do you decide on those? And maybe connected to that, did you try to, if you can discriminate people based on these attributes? So if someone looks cool, beautiful, it's probably me. So so on. Is it possible?
So finally, I show you attributes depend on the skill. Skill of annotation is annotator is very important, and actually the distribution is appear. So that means it depends on the person. It depends on the factor. Don't you think so?
The annotator, you mean? So
Yeah.
Yeah, so if you would, I know there's work on face recognition, for example, before deep learning, there was these papers for LFW where you had 50 attributes, like, do they have a mustache, do they have gray hair? And then based on all these attributes, they were trying to come up with a classifier that would, let's say, be complementary to a feature-based classifier. So I was just wondering if something like that would be also possible.
Yeah, of course, it may be possible, but that's so easy.
Yeah, can imagine.
Because your question is generally we can select one of them. That is very difficult. If you give the please check the beautiful or not. In that case, we can easy to select. But beautiful, cool, that is more difficult question.
Okay, because of time, please join me to thank Brother Uchi again.
Thank you.
Okay, may I pass the mic to Vito, the chair of the next emerging topic.
Requested the chair already, I think you accepted. Yeah, that's okay.
Yes.
Online, so
Very interesting.
So I can do the introductions. So this brings us to the last invited talk of the workshop. And it will be a keynote by Professor from the Chinese Academy of Science. So maybe if I just quickly introduce Professor Chen. So he's an ACM fellow, an IEEE fellow, an AI fellow. So really a renowned.
Hello? Can you hear me?
I can hear.
Okay, thank you. Yeah, good afternoon, everyone. I'm very sorry that I cannot attend this workshop on site as a visa program. I applied my visa in the beginning of April, but I still cannot get it. So I have to attend this workshop online. Thank you for your attention.
Can you hear us?
Yes, I can hear you. Can you hear me?
We are not able to hear you.
Okay, can you hear
We
me?
can see you although.
I can hear.
We can see you. We can also see your slides.
You're not connected.
Yeah.
No,
There's no round.
no. Without this, just
Ah.
video. This will come after by connecting inside. But let us see without this in the Zoom. So looks like we can see your slide. We can see your face, but
Yes.
we cannot hear you. So
Cannot hear me?
could you please
Also-
check settings from your side?
Okay, I check my,
I know you have two login. Another,
Yes.
so can you, yeah, I think you can exit one login. Because
okay, I exit.
you
one
have two,
login.
because you joined twice, so I admitted you both the time, but I think maybe that's the reason.
Okay, can you hear me now? Can you hear
We
me?
can see you. I know you are speaking something, but I don't think any one of us can hear us so far.
Okay, yeah, sorry.
We may need to.
On the Zoom, we can hear again.
Yeah, can you hear me?
What the message is?
Can you hear me?
I can hear.
On the Zoom call.
Oh, you can hear on the Zoom. Okay, that's a message.
So it's our problem.
Okay, can you hear me?
But I'm also on Zoom only, right? I am the host, in fact, right? So,
Okay, yeah.
so far we have 3 presentations also like this. It was working, right?
Yeah.
Yeah.
Mhm.
Yeah, can you hear me?
Let us see, what can we do? I think this is, I have to, yeah, we can hear you. We cannot hear you, but we can see you very clearly. Very nicely in when you shared your slides also.
Maybe redo.
One thing to try is you could log off.
Yeah, I think you're probably, okay.
Yeah,
I
could
will-
you please log off and log in, because you are logging from 2 places in your account, or maybe the name is same. Yeah, and then try again. Less likely we have issue, right? You can see audio is okay. This is okay. So this will come second, but at least we should be.
It's normal.
Yeah, cover the setting for the mic.
Our is goal is it's working. You see, I'll admit him and then maybe I'll make him co-host also. Let me see.
Before this microphone change there may be multiple microphones.
Yeah, let me make him give him co-host.
hear me?
Go on up. Where is he?
Can you hear me now? Hello? Can you hear me?
Yeah, please try this time.
They should have a talk on Zoom for morning session.
Yeah, please try this time.
Can you hear me? Okay. Can you hear me?
Yeah, we can see you, but we cannot hear.
Okay, yeah,
Can you
I don't
hear? You're also on Zoom. Can you check? He was. We just logged out.
Oh,
After
sorry.
stock is over. There is a claim somebody can hear.
Yeah,
I can
Can you
hear
hear me?
everyone. I can hear everyone. I'm on
You're here?
Zoom.
On Zoom, we can hear everything.
Yes.
My machine.
can you hear me?
No, but you cannot hear. You have to join it. Use the same link I sent it to you. Click and can you join?
That is a good idea. No?
No, but you have to hear. Are you able to hear?
Oh.
No, first you join
Yeah.
and then see. You can
I'm
hear
waiting,
me.
You're waiting.
You're waiting. Let
Mm.
me see. I don't get
Let's change the
waiting.
machine. So.
No, I will change it, but at least you are able to hear.
Yeah.
I don't get your request.
I'm sorry. Yeah, can you hear me? No,
No, still not.
you cannot?
Oh, she can hear. You see?
I can
This-
hear everyone.
she says she
I
can hear.
everyone.
Thumbs
I,
up.
I think it's the
Oh.
workshop
Why it's
venues.
our problem?
Yeah, can you hear me? Can you hear Shilin?
Or you sent the report?
Prof.
Yeah,
Chen,
I
I can hear you, but the venue cannot hear you. The
Yeah, I think you're
CVPR
probably
venue.
yeah, that's a
Stop recording,
control
let us see.
center. Yeah, the program from in control center, because yeah, someone can hear me, so I don't
Right
think.
here, right?
No, it doesn't look.
Right? I don't have any permission for request. You
Can
can
we check the mic if it's the correct one? So the
I have only one. This is working good whole day. Absolutely no problem. But maybe one way is that I can.
Yeah,
But I don't get even request for your thing. I cannot see you also, right? You can see.
yeah,
There's
you
no,
can see me? Can you show me?
yeah, your request is not there at all.
I miss.
Pardon?
I tried the second one.
Yeah, that, but it's still, I can claim back the request. Let me see.
Sorry.
I gave him the host.
If you gave them host, can you log out? and log back in?
Of course I can, but I will do that.
I mean, I don't know.
No, I have to restart it. Then all the people have to get one by one again, you know. That's so that's why I'm trying to avoid it being logged out, because I have to give each one of them once again, and then there'll be a break. I have make you a host. I believe you can hear me. So can you return back the host to me?
Just to click or right click here. Maybe you can make yourself host.
Change, we see just a minute. No, I did him the host just now. Let
Yeah.
me see. It allows
Can you
me.
hear me?
So maybe here, if you can do it.
You want to do it?
Yeah, let's try. Reclaim host.
Your request has not come.
So some request came in now. So I reclaimed the host.
Yeah, there is a.
So now I just admitted two people.
Yeah, there's always anybody you admitted.
Yeah, here's Professor Yagi.
Oh,
yeah.
What did you do? How do you get this list?
We just reclaimed it, the host.
Oh, you can reclaim it. Now you're online.
Yeah.
So
Connect by this one?
Can you hear?
Can you hear anybody?
Yeah.
Oh, you can hear me. That's what it is. Yeah.
Yeah,
Can you try again to speak?
Yes, I'm speaking. Yeah.
Yeah,
Can you
okay.
hear me?
Yeah. Okay. So hold on.
Does it work?
Just a moment.
Okay, thank you.
Last talk. So.
There has to be something.
Yeah. Get tired since morning. Let me.
Can you hear?
Yes, I can hear you.
And we can hear you now as well. So.
Okay, thank you. Yeah.
Can you share your slides, please?
Okay, I will share my slide. Okay. Yeah.
Is he co-host?
Yeah. Can you hear me right now?
Yeah.
Okay, thank you. Yeah, sorry, yeah, for the inconvenient online. Yeah, actually, I applied visa for about 2 months, but yeah, I still cannot attend this workshop online. Yeah, okay. Yeah, good afternoon, everyone. This talk is about, yeah, I focus on, yeah, non-verbal communication in recent years. Yeah, because I think this is should be a very interesting topic and very important for the AI age, and because yeah, more and more AI become available, and we need the technology to serve the people more better. So yeah, I would like to start with this, okay, clip, sorry. Why?
Oh, no, hold your fire! Hold your fire, do not fire! Put 12 amps in these animals, they're never gonna trust me again. Luke, stand down. Stand down. Hey,
So I just
what did I just say?
clip. Okay, yeah. So just as shown in the above clips, nonverbal communication is very important. I think for robots, yeah. So in the future, we need to equip the robot with non-verbal communication capability. As non-verbal communication is quite different from verbal communication, which, okay, have hundreds of languages. We can communicate with each other speaking different language, but we can communicate with everyone, even animals, with non-verbal channels. Just like smiling, always a sign in our human society. And as just now, we cannot talk directly, but the emotion expression also show me that I'm working. Yeah, I'm trying to connecting, and if for this purpose, this is not the first time we take attention about nonverbal communication. As we know, Charles Darwin, he worked on this topic. If anyone read this book, the expression of emotion and in man and animals, you will know that hundreds of years ago, Darwin noticed this is important channels between human and also human and animals. Verbal communication and non-verbal communication usually play different roles in interaction. Sometimes the two channels are consistent to enhance each other, but sometimes they are conflicting. From the degree of support to verbal communication, from against to most support, they play different roles. Like okay, conflicting to the verb channel and enhance the verb channel as repeating, accenting, and complementing. Non-verbal channels sometimes also play standalone roles in communication, just like here, said no by shake his hand. And sometimes non-verbal channel even can be used to as control a conversation, like the click in the right parts. The person change his pose, and meaning that we should stop the conversation. And also even for robots, I think as we are now in a big change, and I believe the robot will be very important partner in our daily life. It's also need to have the capability of seamless interaction with human being. Just like in this clip, I show you this clip, it's from the movie of AI. So we know that even for robots, it will be very important for non-verbal communication. Although this is only a science fiction movie, it does imply that this non-verbal channel are very important for future robots. This community works on biometrics for many years. We are working on biometrics for many years. And I think, because we, sometimes I think most of us, are quite confused what the next for us. I think, the advantage for us is to work on the nonverbal communication, I will talk about some efforts in related works. First, even we have working on face expression for many years, but I think we should, from another view, to revisit face expression for robot, make robot to understand our expression, even understand the emotion of us. It's different from previously working on facial expression. A lot of, we work on post facial expression for many years, but in real world challenge, it's a little bit different because for the post expression recognition, we always assume that we have a frontal face, but in real world, it's different cases. Usually will be non-front faces. How to deal with this non-front view expression recognition. So we try to disentangle these two facts, expression and pose. Here we propose a method. This is first published in CVPR, then extended to the PAMI. And the basic idea is to disentangle the two facts into two loops. And for each one, we try to reconstruct and from the synthesized, or generated source faces. And we measure the distance. Then we get the distinguished facts for pose and expression. For detail, you can refer the paper. And here is an example. We have some query images, and we get the retrieved image in AU change, the same AU change, or the almost similar pose change. The order is the similarity. So this get quite good results to distinguish AU and the pose. Here we integrate the functions all together, and we can get this is an integrated face system. I don't know whether it can play now because the decoder in my laptop seems doesn't work for these clips. And sometimes we probably need to understand more detail about expression or deal with a very complicated expression. It's not same as we working on the pure single expression like neutral, happy, sadness, fear, and so on. It may be sometimes very complicated. So language will be a powerful tool and we need to bridge expression and language. For example, we have an image and then the robot can generate a couple of sentences to describe the expression. This means that we could really understand the complicated expression. So for this purpose, we design a 3-stage training frameworks for facial expression caption to generate the caption incorporates with the GPT 3.5. As you know, GPT become popular, and we quickly use the GPT incorporate with our work. The 3 stages are synthesizing the training image text pairs. The GPT helps us a lot in this stage. And training the AU blip and the emotion blip to respectively describe the single aspects of facial expression, and then training a whole expression blips, utilizing the synthesized data with fusion the caption of the previously two parts. Okay, to training the image captioners, the AU and the AU and emotion blips are respectively to spatialize for AU and emotion. We constitute the training image text pairs by synthesizing description text based on annotation of AU and expression category. Okay, here is the first we use for the AU caption from GPT parts. Here is the example. Yeah, you can see here is the example for this parts. Okay, to ensure the diversity of training text, we also utilize GPT-3 to synthesize description for facial actions. However, the output of GPT 3.5 are uncontrolled, and it may be including some reintroduction of AUs. To avoid this situation, we design a one-shot prompting strategy. Like here, we mentioned that, okay, don't describe the emotion expression and don't mention AU in the reply. So we design the specific questions. Then we get the reply about the description of AUs. Okay, to training this two AU blip and emotion blip, then we have the pairs. We try to train that one, and once the two captioners are trained, then we could train the final the final expression blips to describe on both aspects. And then finally we get the final one and the output. So we get the zero shot promote, and we get the output, also the output from GPT 3.5. Then we have the peers for the training. Okay, so this is a very interesting work, and we just submitted to a conference. And hopefully this will be published soon. Okay. Beyond the expression, we think the gaze is another important cues for human and robot interaction. As it says that eyes are the window to the soul. So eyes do provide a lot of information about person. Try to make robot to understand nonverbal communication, especially the cues from eyes are very important for nonverbal communication. And because the eye regions are relatively small, it doesn't like the body or face. So the training data collection is probably different from in real world cases for other like body action, like expression is much more harder to collect the data. So the real challenge is when we have set up like here, this is not our work, to collect data in the lab. But in the real case, because lighting change a lot and also the environment, so how to transfer the gaze estimator from source to target is a really challenge for this kind of work. And we proposed adaptive gaze estimator in 3 steps. Okay, this is a 3-step method. First, we collectively training a face enhancer. we have two one enhancer and one gate estimator. And this is not a single estimator. During training, we will reserve the trained estimator in different times. So we have a bunch of estimator for second step. And then we fix the phase enhancer. We will not change the phase enhancer again. And for the bunch of the gate estimator, we will using the unlabeled target images to go through the gate estimator. And then we will have several results, as you know, and we calculate the variance for all these results. And we hopefully the variance should be as low as possible. If it's very high, that means, okay, maybe this gate estimator not work well. And meanwhile, we also using the average from all these gate estimators to get the pseudo labels and measure the error between pseudo label and the output from the above a bunch of estimators, and then feedback to the gradient feedback to change the weights, to change the model of the gate estimators. Once we have this one, and we will using the average of the training bunch of estimators to get the final prediction. Here's the results. We test the proposed method on several different data sets, including ETH, X-gates, gates 3, 13, and also map gates and LDAP. So from here we compare the results with and without phase enhancer here in the last two rows. And we can find that with the phase enhancer, the result is better. And even, it's much more better than the previous methods. So in this case, we propose a method without labeling data in target domain. So this will be useful for transfer for the robot. We assume the case is the robot will be training in the manufacturing, and when the people in his home or in some other office or somewhere, it will collect more eye images and without any labeling. And this method should use for these cases. Okay. We try this because, okay, sometimes the eagle view is much more important for gate estimator because the robot is always with the eagle view. So we work on this eagle view. The basic method, as I mentioned in previously, and okay, but it's need to equipped with a transformation between robot and the camera's coordinator systems, and this this could be simulated with point of gates on a screen. So we do experiment on a screen, and one screen here we mount a camera on the top of the screen, and when the people look at the screen, then we could follow the gates. Okay, and here's a video of an eagle view case. So, and this will be also equipped to the robot. Okay. A service robot, it needs to understand the gates among a group of people, sometimes not only one people. For the eagle view, maybe just one person, but in other, like, okay, communication cases, a lot of people, so it need to understand gates among a group of people. The typical gates between two persons, okay, as categorized from psychologists. The gates between two persons are divided into 5 categories. The first one is share, which means that two persons look at the same object, like here, look at the same object, all space. And the second one is mutual, which means that the two persons have eye contact. And the third one is single. This means that the person look at his or her partners, while the others look at away. And the first one, it's opposite of the third one. The person look at some other place while his or her partner look at him or her. And the last one, it's opposite of mutual. The two persons all they don't have any eye contact. So this is the 5 typical cases for eye contact of two persons. Even we have more peoples. This category still could be used for by peers and pairs. Okay. So we have designed a system to deal with these 5 cases, and we also collect a data. This data almost balanced for these 5 cases. The system contains 2 branches. Okay, one for head estimation, and the other branch for scene estimation. The background scene of background. Also provide information about the lighting condition and so on. Then we have the future fusion parts, which use both head and and background information, and also the head position is embedding there. We built this new branch for read and not. For the fusion of that, we go the output will go through 3 layers, full connection network, and output directly the 5 cases. For this kind of research, we collect and relabeling some data. The original data are partially from the Leo and also vacation. The original data is not from us, but we do a lot of work on labeling. And we hire 3 annotators independently annotated on the whole data set. The annotators are instructed on how to distinguish the 5 cases, and all the data are double checked by the annotators, and also the researchers from the psychologists. Okay, and all the clips is in 25 frames per second, and each clip lasts from 3 to 14 seconds. If you have interest in this labeling, it's the original data not belong us. The labeling, you could try this one. Okay, it's available right now. Here is the video shows the 2 partners interaction with their gaze change. Experiment results show the performance is superior to the peers. Okay, and it's significant, like the F1 score. The F1 score is significantly higher than the peers, especially for the share mode, and also the single mode and mixed mode, because single mode and mixed mode is almost the same. It's from either subjective or objective views, so the result is almost same. Okay, and another interesting thing is this is not could be used for interaction, but also for psychologist investigation on some illness like autism. And we use the proposed method to annotate the static gaze patterns for 20 preschool children in 20 private videos at family level. And 10 of the students are diagnosed as autism, and the others are typical development. We named TD and ASD here. All these videos are recorded when the child was playing bubble with his or her teacher. The video are recorded and provided by a psychologist in Eastern China Normal University. Then for each pattern, we perform a t-test, and between the two groups, we have some non-hypothesis is that the duration time of continuing a specific static gaze pattern is the same for these two groups of child. And for the above 5 predefined patterns, 4 of them, the mutual, single, mix, and void, are shown as here. I show the p-value smaller than 0.05. This means that the hypothesis should be rejected. And in this case, it could be used as at least as a assistant for the doctor or for the psychologist to make some preliminary judgment for the child. Not only for the we mentioned the gaze. Sometimes not only the gaze, but also we need to know a more complicated relationship among a group of people. So sometimes we need to realize who is the key person and who is the speaker. Like here, in these 2 images, it can significantly get the information that in the left parts, who is the speaker and who is listening to his speaking. And in the right parts, because the 2 person, if we only from gaze, okay, it's almost same. This seems a mutual case, but from most moments, even in the still image, the one person, the man close his mouth and the woman open her mouth. So we could carefully, okay, we could know that who is the speaker and who is listening to another. So in this case, we propose to understand the interaction activities, not only beyond the gaze, okay, not only the gaze, but also some environment and such like spatial contacts and also relational contacts. Even sometimes different modality like a male and a female voice to judge who is the speaker and who is the key person in interaction. So in this case, in this work, we proposed a method for this purpose. And we considering the relationship of each pair in the image. So if multiple persons there, we will investigate them pair by pair. We use dot size in the head channel to represent the human distance from the camera. And we use pink and soft blue rectangle to mark the person pairs, and all the other persons are marked in purple. We extract features for the 3 kinds of rectangle in different color and fit the feature into a visualization context module. Like here, the light yellow. And we have some detail about these parts. The detail of the visual regional context is shown in the yellow box. Adding information and the feature from each body are fit into the three temporal contexts. The three modules and output are then weighted as video regional feature to reflect the degree of speaking. And also in the almost same case, we have the audio visual context. In this case, we also added the MFCC features to judge the audio visual relation context. And then we have the final results. We combining both features from visual regional context and audio visual regional context to the full connection layer. And then we have the speaker and who is the listeners.
Well, now, if it's on account of money, I come up with thank you, give me enough already. Well, now, if it's on account of money, I come up with thank you, give me enough already. Well, now, if it's on account of money, I come up with thank you.
So, yeah, we have considering different channels, gates, expression, and even who is the speaker. And in another case, the gesture play a very important roles. And it could be as simple as a single instruction, or as complex as a whole sentence, even a whole language. It delivers instruction, emotion, attitude, or a whole sentence. Gesture is useful for nonverbal communication. In some cases, like here in volleyball game, the player prefer use gesture rather than spoken language to his or her partners for tactic in upcoming round. And in very noisy environment like a football game and traffic control, gesture also the best one to deliver instructions. Gesture can also be used to enhance experience in game and also control some physical words, like here to control the flying of a drone. And even more complicated, here is a video clip I show you. Wait, sorry. Okay, the decoder has some problem. The living interrupter for sign language and for the at a rock gig. So it can be used for a lot of as a non-verbal channel for a lot of purpose. Okay. Compared to the other modality or channels, freestyle gestures contain a lot of uncertainty, and it's hard to reach common sense. Because you can see even for some right now for some devices can be controlled by gestures, but the gesture set are predefined by the manufacturer is quite different. Compared to these freestyle gestures, sign language is a well-defined action set and also important to this hearing impaired person. The main barrier for sign language recognition is the limited data source. It's different from like speech has 1,000 hours data source. Here we have I show some data that resource like Phoenix 14. It only has 12.5 hours dates, so it's relatively small. In this case, some maybe some very popular tools like Transformer is hard to use in this case. We make some efforts on gesture and sign language recognition, try to equip the robot with the capability to understand gesture and also sign language. We have developed a method for indoor case with point cloud as input. And we also propose a visual alignment constraint method to make network trainable by aligned visual and context feature to training a better continuously sign language recognizer. We also do some other measurement, like here the radio CTC, and recently we working also on skeleton data because, as you know, the AIGC is very popular. We try to generate some sign gestures, but we realize that it's hard to generate the whole image directly, and we try to use combining skeleton and also face and hand separately to generate such kind of images and videos. And this is ongoing work here. Yeah, to deal with the problem of correspondence, we in point cloud, we set a small region. Yeah, this is very tough, and so therefore we set a small region to do the correspondence because it's hard, different from the video. The video, the problem of pure video is a heavy computational cost, and it's hard to segment from background. And point cloud, the advantage is it's efficient and it's robust, like here. And for the correspondence program, yeah, we try to make the correspondence between one position and its neighborhoods. So we considering that pairs, a set of pairs, and then we update the virtual hidden states for each point pairs with shared LSTM. The purpose of use LSTM is not because the LSTM better than like a transformer or some other method, because you can work well in small data sets. Okay, so then we have a pooling layer to obtain the final states for each points, and then we keep to update the state for each correspondence points for the combination. And for another simple case, because we assume that the action of a person should be consistent, so we just using one single state to replace the state for states for each points, and the whole body share one state, and we get a simple version and almost the same performance like in the more complicated and computational cost cases. We take a modified version of FlickNets as baseline, which utilize only one intro frame point net layers and 3 interframe layers. And we also using a spatial tempo grouping and modifying sample layers to downsampling. From here you can find that from endpoints to half of endpoints and 1/4 and 1/8 in the points. The N here we use is 128. And we conduct experiments on several data sets. For the point cloud, we use not for sign language but gesture, because it's more suitable for indoor gesture cases. And first we tried on the Shrek 17, and the data size is contain 14 gestures from one finger to whole hands, with total 28 participants. And here's some of the examples. And it showed that the proposed method is much more better than baseline because we use the the update by the update by the proposed schema. And we also tried with the NV gesture. It's a that set for make control in car environment, and including 25 categories and about 1,000 training videos and nearly 500 testing videos. Here are the results. The results also shows that the performance is quite better than previous method. And in the beginning, we designed this method for hand gestures. And we also would like to try to extend to large scale motion. So we test on the MSR Action 3D and also get the quite good performance in this case. I will move to really sign language because if we want to get more data, we have to go back to the pure video, not depths, not that grow or some other modalities. And for this case, how could we get the I think reasonable results for interaction? Because we could have a language model to help us to get the better results rather than a single word recognition. And the widely used paradigm in sign language recognition is a feature extractor, then plus a spatial information alignment module like here. But to catch up the visual cues from large scale to small scale, the training schema usually running iteratively, and it will cost a lot of time. So we try to try to reduce the training time with a proposed visual alignment constraint. Because in the schema proposed here, we could find that it's very easily to overfitting with the training samples. Here we could see from the table. From the table, we could find that even it's a different from the training. Oh, sorry. From the training data set and the development data set, the WER changed a lot. The WER's word error rate, and the lower, the better. So for the baseline, it's changed a lot from the training to development set with only half masked training set. So it's totally overfitting to the training set. And for the non-mask, we could find that the performance changed a little, but not so much. Okay, that's the why we try to get new training schema, and we propose the visual alignment constraints to make end-to-end training. The purpose is to speed up the training process. We propose this method, and the key idea is to use this VEC and the VAC constraints. I will show you how to use these two parts. We have in the iterative schema, it's different in two training steps. And in the end-to-end training, we only training for once, and we use a share weighted extractor. We have two. One is the in the up parts, it's a primary extractor, and in the low parts, it's an auxiliary extractor. And the low pass only using the constraint from the visual enhanced constraints. So, and for the up parts, the visual alignment constraint are used to control using the up visual alignment constraints go back to modify the lower feature extractor, and then we get better features in constant with alignment module. That's the purpose. And we tried on the real world Phoenix 14. Okay, that's the this data set contains signing from 9 signers and totally 10.7 hours video and about 5.k training centers. Okay, and from here we could find that we using only 1/7 training time to get better performance compared to previous method. And okay, here's the results. Compared to other peers, and it still keep quite good performance. And most of the previous work are iteratively training. Okay. Here is I think it's more interesting here, and we could find that for the labeling and the ground truth, we have the result from the VACP and VACA. The VACP is with the primary classifier, and VACA is the auxiliary classifier. So finally we're using the VACP. So the results is quite better than the old ones. Different color means different words, and the red one means some arrow. Okay, and we also find that it's pay more attention on facial expression with this VAC control. Here we have more attention on face parts. Okay, but this is the final part 1. We have a lot of non-verb channel related to face, but as we know, we do face related works in different models. Can we try to integrate them together? And this is another, I think somehow many researchers try to do this kind of work to have the altimeter, the altimeter purpose for their unified perception model to integrate all this kind of work together. And this will be more efficient for both memory and the computational cost. And here's some previous work tried on this topic. And it's using a feature extractor, then using a different final level for layer for different purpose. And the most challenge for this kind of work is we do have some dedicated data sets, but only for one training purpose. And how could we using all this public domain available data set into for one task move to for the sharing tasks? Okay, so do we have any we don't have any large scale data set with multiple labels. How could we change the situation for this? And we propose to using the self supervised learning plus the huge number of face image with only 1 or 2 labels to pre-training face fundamental model, then transfer to some downstream tasks. Okay, and here's we propose the method we named the 3D Bell bypass enhanced representation learning. And the basic idea, we have a supervised path for training face recognizer, using the face recognition rules as the criteria for training. Meanwhile, we get the information and to encoder from original input and also the feature decoder from the features, and then we have the information like depth, albedo, view, and lighting. Then we re-rendering, get the image for reconstruction in 3D. And in this case, we have the self-supervised samples, and using this one to improve the training and then transfer the model into downstream tasks. And here's some examples. We only use 5% or even 0.5%, 0.2% training data to fine tune based on the fundamental models. Okay, and we know this fundamental model different for the different from the unified face perception model, but with this fundamental model, we could have more generated faces, and this faces will be helpful in the future. We want to also integrate with the promotes to training a unified model in next step. Okay, and yeah, that's in the future we try to do it. So yeah, before end of this talk, I think the understanding of a person in non-verbal channel is essential for robot in next decades. And for our community, non-verbal communication should be a new focus for our community on research. My vision is look at the people, not only for identity, but for understand the people, for serve the person better. Okay, and thanks for my colleagues, and thanks for your attention.
Here. So any questions? So let me start off the questioning then. So a lot of these tasks are, let's say on behavior, are related probably to culture and age. So can you comment how these models generalize? Because I would imagine usually you would have some training data for a specific part of the population. So how would that generalize then, for example, people from other cultures or younger adults or even children?
Okay, that's a very good question. Yeah, for different culture, that's why we emphasize transfer learning and fine tune. We believe that the basic functions are almost same, and some basic like the eye contactor models are universal, but some may be different, like gestures are different. So we need to transfer for different culture and different environments. And we would like to equip the robot with the retraining all adaptation functions in the future. And once the user have the robot, it can using as less as time to retraining the robot, understand the culture, understand even the behavior of a specific person. I like the movie of AI. Yeah, if you know that movie, it's also the same case when David first go to his home. Yeah, he tried to adapt, and then he become quite familiar with the family. Yeah.
Okay, thank you. So any other questions? Yeah, please.
Yeah, I'm curious that when you are presenting your interesting result on the gaze estimation, I wanted to know whether there was any calibration between the camera and the eyes for the data set for which you are showing result. Second related question. Yes, please go ahead first.
Okay, I will show you. Yeah, for it depends on for this type of work, we don't need to do any calibration because it's only the relationship between the two persons, so we don't need to do any calibration. But for this kind of work, the ego view, we do need to do some calibration. Like here, the ego view. Yeah, in this case, we do need to do some calibration between the camera and also the screen. The screen is here. The screen is in robot case. It's not screen. It's body of robot. So you need to do some calibration. But for the understanding other parts, I mean the object beyond the robot itself, we don't need to do any calibration. It's absolutely not relatively direction to the robot. Okay.
Okay, thank you. Yeah, I got answers for the both. Thank you.
Okay, thank you. Yeah.
So any other questions? Maybe I have another short question. So we had a talk earlier on synthetic data, and I was wondering, so in the behavior recognition space, is there work on using synthetic data to train these models?
Yeah, right now we have some very preliminary work. We don't have any completely evidence it will work for this kind of job. But we do try to using the synthesized data in the future. Once we have any results, we will publish both data and algorithm. Yeah, right now we combining the actions in different layers for generate the data. Yeah, basically the skeleton for the body, and also a hand model for the detail of hands, and also facial model for a better view of face. So it's still ongoing, and it's really tough for I think to get like a really video. It still has a long way to go. Yeah.
Okay. So if there's no further questions, one more. Yeah, please go ahead.
Thanks for the talk. So you mentioned about this face foundation models. So I'm wondering if we can be even more ambitious, like a human foundation models, like one way to learn from the human, one model learn from human data or different type of human data, and to and then be kind of tailored for specific tasks, including face, gaze, gesture, human body, pose. So can you comment on that, if that's feasible at all?
Sorry, I didn't hear your question clearly. I only know you're talking about the foundation model.
Right. So I'm wondering, it's an open-ended question. So I'm wondering what's your view on even more ambitious goal, like a human foundation model, where you can learn from different modality of human data, and then be able to adapt different tasks, including face, gaze, gesture, human body. Yeah.
Okay. So thank you. Yeah. Okay. This is only personal viewpoints. I think maybe face should have a foundation model, and the body should have another. But I don't think this should be integrated together, because in this case maybe we need more training data, even huge, because they are totally in different scale and different attention. My personal view is we should focus on the almost same scale. I mean, okay, in geometry scale, the same scale case for researcher. If we have the attention cross from tiny scale to large scale, then we have to pay a lot of more attention on data collection, on computing, because a lot of noisy will be removed by much more training data to distinguish what kind of information is really used for this kind of purpose. So my personal view is face could be one and the body could be another. And these two models could be integrated together, but not one model. Thank you.
So thank you very much for the very interesting talk. And let's thank the speaker again for that.
Okay, thank you.
Thank you.
Thank
So-
you. Yeah, we'll move on to the last session today, and I can see Professor Bhanu is online. Just a minute, let me claim the host. Yeah, you can take it. No, I have to switch this one.
Oh, sure.
Because.
Sound is no problem.
Hello, Ajay.
Yeah, I can hear you. Can you hear us?
Yeah. Do you want to put the certificates or should I share?
Both is okay. Okay.
Maybe you can share it.
Okay. So can you hear us?
Yes.
Okay, you want to say something with the closing session before we? talk?
Yeah.
Yeah.
So you just put the certificate, the Ajay and myself, we would like to thank all of you, the authors, the keynote speakers, reviewers, and everybody who helps us in hosting this CVPR workshop. This has been the 21st, 22nd, Ajay? It's about 20 years.
Right.
This workshop has been going on for about 20 years. And as with the traditions, we have 2 awards to announce. The first award is the highest impact award. This award is selected based on the number of citations for a paper which is published in the IEEE, this CVPR biometrics workshop 5 years before. So the highest impact paper award is the title is, Ajay, you can, yeah, the title, the highest impact.
No, it's the best paper award
Okay.
first.
Okay, all right. The best paper award for this 2023 biometrics workshop goes to Chia Zheng Chang, Li Yao Chen Wang, Lai and Chen. And the paper title is A Closer Look at Geometric Temporal Dynamics for Face Anti-Spoofing. Let's congratulate to all the authors.
So maybe I invite on the behalf of authors, one of the author is here to receive the certificates which has been signed by you. Yeah. Thank you. Congratulations.
And there is a certificate for everyone.
Yeah. Inside. Thank you. Congratulations. So let me describe the process. What we do for the best paper award is we typically pick up 3 best nomination in the judgment of the program chair, you can say, based on the feedback we have, and we pass on to him for judgment, and we get the decision. So this year we have done the same process. Yeah, please move ahead. I think one award is over. Yeah. Next one is a highest impact paper award. Yes.
Right, and this award is based on the paper published in the biometrics workshop 5 years before, and the award goes to Ortega, Perez, Morales, and Tom. And the title of this paper was or is a time analysis of pulse-based phase anti-spoofing in visible and near IR. It looks like the highest impact award and the best paper both are in the area of anti-spoofing related with the spoofing. Let's congratulate to all the authors of this paper. This paper had the highest Google citations.
Thank you in the name of the authors.
Thank you.
Thank you.
So this award is largely based on Google citations, Google Scholar citations. So it's quite easy to pick up from a couple of years of workshop. We generate Excel sheet, and then I just send him to have a look, and then the award is picked up. Yeah, so I think we have completed the distribution of both of these awards, and for the highest impact award, one of the colleague from the winner authors lab, that's a winners authors, has already taken these certificates. Now over to you. Would you like to say something more before we close the session?
Yeah, I would like to say a few words. We would like to thank everyone, and I would like to really thank Ajay extremely. He works extremely hard, and in every year the program committee has to be reset, and the entire review process has to be all set up, and he has shown the highest passion and the highest ethical values in conducting the review process for CVPR and hosting this meeting. And he has been of immense help. So we would like to thank all the authors, keynote speakers for taking their valuable time in different time zones and all that, and the reviewers, authors, and the participants who were live or who were on Zoom. Thanks to all of them. Now is the time to enjoy the CVPR and enjoy the dinner today. Ajay, you have something to say?
No, I think we just want to thank the authors, reviewers, and the participants. Because of them only, the workshop has been running for several years. So we
about 2 decades.
Yeah, about 2 decades. Yeah. So I think it's the longest consistently running workshop in CVPR in the best of my knowledge, I think. Yeah. So yeah, I think hopefully this achievement of yours would be recognized by others also some point of time. Yeah. Yeah, that's it. Yeah, I think we are good to close this workshop, and we really thank all the participants for being here so late until the last session to make this event lively and very successful. Thank you.
And our best regards to all of you. Thank you. Bye.
Oh, yeah, sure. Yeah, thank you. Thank you so much. Yeah. It was of immense help in the last time of the crisis. My laptop gave up. It was working hard since morning. Thank you so much.
Yeah, no problem.
Thanks. Yeah, it was very much helpful. Like I don't